So, right, as I was saying, thank you all for coming. I would like to apologize for missing our meetings for a couple weeks. I had two friends die tragically, very young in accidents recently, as well as a father who had to have emergency surgery. Usually, I don't share those sorts of things with my students, but when it impacts what we have to do with the class, I think I need to share it with you. But we're having a memorial for one of my friends tomorrow, and then I'll probably have to fly to San Diego, where one of them was from in the coming weeks, once it's decided what's going on with him. Dad is fine though; he's recovering just fine, and he's throwing his annual Super Bowl party on Sunday. So I wanted to let you all know what was going on. So to review, let's talk about what we've been talking about online for the past couple weeks. Let's share the screen. So, to review the basics of business strategy, we defined business strategy during our first live meeting as competitive plans we implement in the business, a set of principles and rules in a company set to achieve its goals and improve its business value, and a plan where we define our vision, mission, goals to meet the challenges and objectives in a business. So our business strategy is formed by several components. One of them is the business mission. The other one is the business vision. And what is the mission, if we can review what that thing is? What is the mission of a business?
This is Marvin. I'll take a stab at it. Maybe it's their objectives or their goals.
Well, don't take a stab at it. This should be very much reviewed from the past couple weeks. So, what is the mission of a business? Because all this should be reviewed by now.
It's a clear and compelling statement that unifies an organization's efforts and describes what the firm is all about.
By statement that describes what? Sorry, say again, please.
An organization's effort and describes what the firm is all about.
Good. So, what
they're working toward?
Sure. Well, not that what they're working towards, what they do. So what they're working towards is actually their vision. So let's talk about mission. What do you suppose, if you had to write a mission for a university, I suppose the missions for most of the universities should sound pretty much the same. What do you suppose the vision for University of the Cumberlands might be if you had to guess?
To provide excellent Christian education.
Okay, that sounds great. Actually, that's great. So a lot of times I see missions that are overly long and broad, and they're trying to touch all different sorts of things. The best mission statements are very, very simple. Somebody for me, please look up Google's mission statement. I love Google's mission statement. Type it in the chat box so we can all see. Google's mission statement is so simple.
To organize the world's information and make it universally accessible and useful.
Yeah, does that just pretty much describe it? It's very simple, but does that pretty much say what Google does? Organize the world's information and make it accessible.
Sums it up nicely. Clear and concise.
Yeah. There are lots of places that I've seen very, very long, rambling mission statements, but the best mission statements are short, concise, and they say exactly what a firm does. Now, how does that contrast with the vision? And again, this should all be reviewed.
It's the plan of maybe how to get there.
It's not the plan of how to get there. Actually, so how to get there is actually the vision. Or sorry, where they want to get is actually the vision. The plan of how they want to get there are these things. So the vision is what? It's actually is what a firm hopes to.
Well, as I was researching it, it talks about a company's roadmap, indicating what the company wants to become. So it's setting that clearly defined direction for the company's growth.
Yes, yes. It's what they hope to become or achieve. They haven't achieved.
And also, it's a company's main agenda is called a vision. Like a motto, I mean, the do's and
Say again?
the company's roles. The do's, I mean, what the company does and what is the future of the company in next coming years and all.
Yes,
that's
good.
Called a vision.
Is always forward looking. The mission is what we're doing right now. This is what we're doing, and this mission will help us achieve this vision. So what do you suppose? Okay, we're saying a very concise possible mission for University of the Cumberlands. If we're going to write it, now I'd almost say that this is a little bit too concise, especially because to me, Christian education. It sounds like we're a it sounds like we're a what is it called? What is it called when we provide only religious education? We're a seminary. It sounds like we're a seminary. We're only providing actually Christian education. We're providing much more than that. So to provide quality higher education, maybe that. Does that sound about right?
Yes, and I think University of the Cumberlands really does a good job of trying to make it available through technology. So I would probably add something about that if I had time to wordsmith it.
To provide quality and accessible education guided by Christian values. Higher education guided by Christian values. Sounds good to everybody?
Yes.
And of course, now this is not the mission, but it sounds like it would be a good mission. So let's say, what is our vision? If this is what we're doing to try to achieve something, what is that ultimate thing we want to achieve? What do we want to become?
Maybe the top online something university. I would probably have some kind of point in there for something we're trying to achieve. So to be the premier online education, provider for working adults or something along those lines. Well, I guess you don't have to be working adults because they have, they offer schooling for kids on campus. But
now it's not just online. We've got a real campus. I don't know how to make this.
Right. So to be the premier online and, I don't know. Some of these things that you're asking to require a little time to think through. So it's hard to answer off the cuff.
Sure. Anybody else have any ideas? Sure. To be the premier online and on-campus university, or something like that. All right. So these are the two things that we start out with first with strategic planning. We have a mission and we have a vision. This is what we want to. This is what we want to become, and this is what we're going to do to try to get there. And we are not here yet, and we are potentially not living this mission to our fullest. That's where strategic planning comes in. We are not here. We are not the premier Christian online and on-campus university. Why are we not here? And we are not here because there are problems. There are issues. There are things that are preventing us from achieving our vision. What kinds of problems, what kinds of things that are going wrong does potentially does University of Cumberland potentially have that is preventing us from being the premier Christian online and on-campus university?
Well, there's always money or finances.
Lack of funds to lack of.
Maybe like policies.
What about policies?
We have to adhere to the policies and such like that. So, for example, in the finance institute, you need to have SOX compliance, something like that. For the universities, we don't.
You're trailing off. Can you say that again, please?
So, for the financial institutions, we have the compliances like Sarbanes-Oxley Act. So that is mandatory for all the all the financial institutions.
Yeah.
So I mean, it's not a problem. It's more of a like compliance. So maybe in the initial process, it takes some time to make sure of that, I guess.
Now, this might be a problem, or maybe possibly regulatory. Maybe possibly we have a lack of time.
Yeah, that sounds yeah.
That sounds better. So we have these regulatory requirements, and we have program improvement efforts that we're trying to achieve, but we can't do both of them, or we don't have the time and resources to do both of them effectively. So that's possibly a potential problem we're encountering. Any other problems do you see in possibly University of the Cumberlands might be having?
I think with any organization, you always think about HR. You want good professors,
Okay.
good admin.
All right, so those are things that we want to have. But what about the problems? What problems do we have? Do we not have good administrators? Do we not have good professors yet?
Well, you're always wanting to seek improvement. I mean, if you're saying the best professors are at Harvard and Yale, then and we don't have them at University of Cumberland, then that's an issue.
So let's see.
Maybe along those lines, just forward-thinking professors. Sometimes we have folks who are just stuck in the way of doing things and not maybe their ability to think outside of the box and deliver education in a unique way.
Well, yeah. So right now, so we're supposed to have recorded lectures. Actually, when I interviewed for this position, they said, "Are you okay with having recorded lectures once a week?" I said, "Well, yeah, but can I do live classes instead?" They said, "Hell yeah, that's even better." So even what we're doing right here is an improvement over what actually the requirements are for this course. They said, "No problem. You can do recorded. You can do live lectures as well." And I love
right.
Actually,
yeah, I think along those lines too, you bring up another point that could be a problem is available technology.
Yeah, so actually, this GoToMeeting thing, this isn't provided for us. We don't have a live video conferencing tool, so I'm paying for it. So lack of technology.
Actually, in Blackboard, the Collaborate Ultra is I've used that as, or I've seen that used as a live
Is it live like this?
Yeah,
Okay.
before.
I've participated in one of those.
Nice. Okay. We can try it for next time. I haven't seen all the tools that we have available to us. Sometimes the university pays for them, sometimes not. Especially when they're not required, the university definitely doesn't pay for it. So we've got 1, 2, 3, 4 problems here. After we've identified our problems, we identify our goals or objectives, things that we want to do. And if we remember, these things should be SMART. What does SMART stand for?
Specific, measurable, attainable, relevant, and time-based.
Correct. Specific, meaning we have to say we want to do this particular thing. Don't say we want to improve performance. What the heck does improve performance mean? We want to improve something. We want to improve student enrollment. We want to improve faculty credentialing. We want to improve faculty training. We want to improve student engagement. Be specific about what we want. Measurable. Don't say merely that we want to improve. Say by how much. Say we want to improve student engagement by 50%. We want to improve faculty credentialing by 20%. We want to improve collection of funds in our annual campaign by 25%. Everything should be measurable. If we pick something that is not measurable, so let's say we want to improve student satisfaction. Well, if we don't have a tool in place to measure that, then we can't really measure. Then we can't really have a goal to improve student satisfaction because we don't have a way of measuring it. I spent several years in program assessment and evaluation full time, and we always have to have some kind of tool, some kind of measurement, some kind of rubric, whatever it is, to be able to actually put numbers on anything that we're trying to look at. We can't just say that we want to improve something if we can't actually look at it and say show a noticeable, measurable, quantitative, or possibly even qualitative improvement. And the A stands for attainable. We don't want to say that we want to increase the amount of funds we're gathering in our annual campaign by 100% if we simply cannot do that. What's the A again? Is attainable and realistic? Let me make sure I got these correct. Let me make sure. Let me make sure I get these right. Right, okay. So attainable, yes, good. Attainable means we don't want to say that we want to improve contributions to our annual campaign by 100% if that's simply not attainable within the time frame that we set. Relevant. Don't say that we want to improve contributions to the annual campaign by 100% when it relates to the lack of technology to deliver high quality education. It needs to be related specifically to the particular problem that we're going to deal with. And then time bound, you need to have a deadline. Don't say that we want to improve something if you're not going to say by when. You have to say by when we want to be able to do this thing. Otherwise, it's not worth doing, or it's not really worth putting in our strategic plan. If we just say, we'll get to it eventually. We'll get to it eventually. We have to set a specific deadline to achieve these things. And then what are
Dr. Moore, is that in the book?
Huh?
Is that SMART, the acronym? SMART acronym, is that in the book, or am I just
not sure.
glossing over something?
I'm not. Is it in the books? Is it in the book? Does anyone know? I actually haven't read the book. All strategic planning books are exactly the same. Yeah.
Thanks.
I can pull up the textbook and make sure it's in here. But also, I've done these courses so many times, and all the textbooks are always the same. I don't even open the book for most of them anymore. Has anyone who's
I looked for it.
in there?
I looked for it, but I couldn't find the acronym of SMART in the textbook at all.
Let me make sure. I know that I've talked about it. I mean, I've read this class, I think 3 or 4 times before. Where did I do with the textbook? What did I do with the textbook? I'm not going to look for it right now. But
Well,
sorry, say again.
I was just going to say I didn't see it in the textbooks either. It's something that we refer to regularly at work, so
Okay.
that's how I knew the answer.
Okay. Definitely mark this down. If it's not in the textbook, it should be. And whoever wrote the textbook is not very good if he or she didn't include this portion. And then what comes under goals and objectives? We have strategies. Now, what are strategies?
Plan, direction.
They're not plans.
I think they are. I beg to differ because we come up with them all the time at work, and it's a plan to get somewhere. So it's a strategy. You take information and you build your plan, and it becomes a strategy.
Or the goals, according to the book, it's the goals.
Goal. It's a general sort of. It's a general sort of. It's not a plan in particular. It's a general sort of methodology that you're going to employ. So regarding strategies, a strategy for.
Okay, real quick though, I've got something to say. I did look it up in the dictionary, and it says a plan of action or policy designed to achieve a major or overall aim.
Yeah, I think policy is more appropriate, not a plan of action, a policy.
Strategy. I looked up strategy.
Yeah, I don't like the word plan. Plan sounds more to me like this overall thing. This whole is a strategic plan. Strategy is much more
okay. Well, it's in the dictionary, so just so the class knows.
Okay, we can do the contrary, or we taking an observation. Hello.
I'm sorry, I didn't hear what you said. It cut out.
Are you being contrary, or are we just making an observation? Do you want to argue this, or you seem like
I do. Well, I don't want to argue it, but I just want to state that I did look it up in the dictionary, and that's what it says. So I'm sure you'll build upon that, but generally speaking, it is a plan.
It's. What about does the textbook have a glossary? I don't think it does. Right. Anyway, so yeah, I prefer the term policy. So what might be a strategy that would help us achieve the goal or objective of increasing contributions to the annual campaign by 25% within the next 5 years? What might be a strategy we could employ? A general policy or principle that we might add to help us get there.
Maybe increase according to inflation rate.
So that's more along the lines of a goal. What's about a strategy? Some policy, some overarching principle that we might employ to get us towards that goal.
Maybe governance.
Say again?
Governance.
Okay. What about governance in particular?
So more of it's a management, and everyone has to be a part of it, and we use the information technology as well to enforce that. I mean, that's what I think it is.
I don't know. Anybody else have any other ideas?
So it's a list of principles that can be used in making a particular decision for any organization.
Yeah, I like that, policies and principles. But what particular policy?
It's a collection of mechanisms and procedures of a business.
But what specific? We've done a good job of defining it. But what might be a specific strategy to help us achieve our goal of improving contributions to the annual campaign by 25% within the next?
Maybe the objectives of a particular organization, collecting the objectives of a particular organization.
We've defined it just fine, but what might be a specific strategy to achieve this specific goal?
A gap
How
analysis.
about increased research, maybe, that generates revenue?
Oh, okay. So, a strategy might be, let's see, let's call this, publicity and recognition through research and publications. So help us achieve the goal. Let's write the goal. We might want to work on publicity and recognition through research and publications. This will help alumni and potentially other organizations that might want to contribute to our annual campaign to contribute to the university, because they know that they are contributing to a valuable cause, that we are actually contributing to the scientific community through lots of research and publication. And what might be some tactics we might employ? What are tactics? These are the specific actions that we will take to make this happen. So what are the tactics we employ to improve the publicity and recognition through research and publications? These are specific actions that we're going to take to make this happen.
I mean, my understanding is tactics are your approach towards the issue.
Mm-hmm. What will these be?
I'm just thinking.
For publicity, you'd have to define which avenues you're going to use. So are you using social media? Are you using ad campaigns? Are you using billboards and those kind of things? That might be a tactic.
Okay. So let's write it. So let's say we want to use social media. Let's say use Twitter to publicize and promote student and faculty publications and presentations. So whenever a student or faculty member publishes something or presents somewhere, we'll post it on Twitter to get that recognition out there, to get that name, so people will see, oh, Cumberland is stuff, and we want to contribute to that. That might be a particular tactic that we put Twitter, let's say Instagram, and LinkedIn, to publicize and promote student and faculty publications and presentations. So every time somebody publishes something or presents something, we want to publish that on Twitter. So there we go. This is the sort of thing we'll do to be able to put together a strategic plan. And we will have all these problems, goals, strategies, and objectives, and we will set these together, put them in a nice book, and present them to our creditors and present them to our board of trustees. They'll approve it, and they'll tell us whether we want to do it or not, how much funds, and yeah, it'd be great. So this is what we do, basic overall in business strategy. Now, answer me this question: why last week did we talk about Bitcoins, and why this week are we talking about what's the topic for this week again? I forget. I remember talking about it recently.
Virtualization.
Virtualization. Good.
Are you asking why did we make that big jump, or what are you more reflective kind of question?
Well, the topic of this course is information technology in strategic planning. Why then do we jump from all this overarching stuff and then run into specific technologies? Why are we looking at these specific technologies when it comes to strategic planning? How are they relevant? Let's talk about Bitcoin's cryptocurrency and blockchains, for example. I presented a lot of follow-up questions to you guys because some of you didn't seem to get it right on what these things actually were. A lot of you seemed to think that Bitcoins and blockchains were synonymous. A lot of you, one of you even said that blockchain seemed that Google Docs used blockchain, which I don't think it does. I asked you to go ahead and recheck that. So some of you weren't quite right with what you posted. Hopefully you made those corrections and reposted. But why is this important when it comes to IT strategic planning? How might an IT strategic planner, a CIO, a CTO, or even a CEO, how might these people keep these things in mind with regard to strategic planning, and how might they be useful?
Yeah, I think that's like you go from vision to actual implementation, like the overall blueprint. This is Marvin. So so you get the overall plan, and then you get the actual down to how the building blocks are, which those are like current things that we're considering: Bitcoin, cryptocurrency, and blockchaining, and even going into virtualization. All right, so these which is what you're teaching us
that we might be implementing in our tactics. So we need to be aware of all these emerging technologies, because when we have our goals and objectives, we might need to be aware of these technologies to be able to use them and plan to use them in our tactics. So let's look at Bitcoin's cryptocurrency and blockchain. What might be a specific strategy or even a problem that might be addressed by a tactic utilizing blockchain, or possibly even Bitcoins?
What I would say that, I'm sorry, go ahead.
No, go ahead.
No, I was going to say the current institutions, Wells Fargo, Bank of America, they're not on board. It's not in their purview to look at these items and say, hey, this is legitimate, and they're missing out.
Okay.
It's not.
Let's keep the organization with which we're all familiar with, University of the Cumberlands, in mind. How might University of the Cumberlands strategically use these technologies in its strategic plan? So we talked about we wanted to provide quality and accessible higher education. How might Bitcoin in particular help us achieve accessible higher education? What about Bitcoins makes it more accessible than US dollars?
generally speaking, I think Bitcoin might not be that productive for the university, but maybe you can use the blockchain because Bitcoin generally, if you are using it for any transactions or anything, that will take a long time to process, and university needs to set up a service to process them. So I don't think that will be productive.
Well,
And
let's talk about how long does a Bitcoin transaction take to process?
I mean, I don't have the figure with me as of now. The thing is, it continuously evolves. So the processing for one transaction takes a lot of hashes, like a lot of computation. So it depends on the algorithm and
I think it's roughly around 2 hours.
So
yeah.
I just asked Google, how long does a Bitcoin transaction take? It can take between 10 minutes to a day, and the average transaction time is an hour. And that is for a confirmed transaction. That is, this transaction is done and complete. How long does a credit card transaction take?
Yeah, it's virtually instant.
No, is it though? Is it though? Is a credit card transaction instant?
I mean, the
No, I don't think so, because the money doesn't flow from the bank to the merchant when you know, on the instantly. It
Right.
definitely takes enough days.
Right. So a credit card transaction actually doesn't settle. It's called settling. A check for a charge is put on the account right away. However, it doesn't, quote, settle for a day or two. And also, the merchant doesn't get paid for a day or two, or possibly even until the end of the month. They might only get deposits once a month. So actually, credit card transactions do take longer than Bitcoin transactions. We may think they're instantaneous, but it actually, the merchant does, or in this case, the university, wouldn't actually get the money until a couple days later after it actually goes through. So that's one thing. What about electronic checks or even paper checks? How long do those take?
I guess they take like at least 4 or 5 business days.
Yeah, so again, it seems instantaneous. The way we look at it and the way we see it happen, we could say, yep, thank you, your payment has been processed. However, it takes actually several days for the check to clear through the automated clearinghouse, or the ACH. So actually, Bitcoin payments are the fastest that we've looked at compared with credit cards and compared with electronic checks or even paper checks. Bitcoin transactions actually take the least amount of time compared with these things. Now, there are services that will sort of advance the money to the merchant. Sometimes, like with Square or Cash App, the merchant has actually advanced the money, so it can be withdrawn immediately. But those are actually, if the credit card transaction ends up getting denied, that money will be clawed back by the financial institution. And a lot of times, if an electronic check is made, and the check ends up bouncing, that money will again be clawed back. So it is instantaneous in some cases. However, that is conditioned on the fact that the transaction will be approved. If a transaction is not approved, it will be clawed back. And in the case of a credit card transaction, it will be clawed back within 1 to 2 days. In the case of a check transaction, it could be clawed back within 5 days or maybe even a week. So there's even actually an additional risk with accepting checks versus accepting Bitcoins. Because Bitcoins, you will know definitely for a fact, for certain, if the transaction has completed within about an hour. And the most you will have to wait to see if the money will be clawed back is about an hour. With a check, it takes about a few days to a week. With a credit card, it takes 1 to 4 days to see if the money will be clawed back. It will be if it doesn't go through. So actually, Bitcoins are actually faster than checks or credit cards. Does anyone disagree with that? Or did anyone not know that?
initially I was not about to say that physically doesn't. I did not mean that it takes physically less time. I just meant it's virtually. So yeah. So the bitcoins are generally faster, and generally any crypto is faster.
Yep. All right.
Yeah.
Blockchain. Some of you said the blockchain could be strategically used within the university. How could that be strategically used within the university?
I can use I think we can use blockchain technology to for the quality purposes. Let's say we all write research papers, and these needs. So we need to have a centralized database so that other universities can actually access our papers to find or to see any if a student is trying to do a plagiarism or anything.
So tell me, how would blockchain be useful in the plagiarism case? Can you illustrate that for me? I'm not really following it. I sort of like an example, maybe, if you could.
Again, my understanding is using smart contracts, we can basically share. So every student who uploads a research paper, let's say to university's database, then if we use blockchain technology, then we can write a transaction onto the node.
Yep.
And then I think we can also, so once we have the transaction on the node,
yep,
then other universities can also access it. So I think that right now, if I upload a document in the Blackboard, it takes at least 15 to 20 minutes to check the plagiarism. But with blockchain, I think we can get the result of the plagiarism in like seconds or minutes.
So blockchain, do you know what blockchain is? Do you know how it works? Let's do an explanation of how blockchain works. I don't think that example actually shows you how blockchain works. Blockchain starts out with a hash. So it's all. Let's say it's a 9-digit hash. When we make a transaction on the blockchain, the hash now becomes this. And this are related to each other mathematically by the transaction that took place. This transaction going into this hash can only provide this next value for the blockchain. No other transaction will provide this next value. Only this transaction will provide this next value. So we can verify that this is the correct value by taking the transaction, running it against the previous transaction, and we get this value back. If we don't get this value back, then this transaction is invalid. So if we try to say, so let's do another, so transaction 1, transaction 2, and let's say we get 778 A, B, C, D. Transaction 3, we get 9984 F, E, E, A. So if somebody tries, now, and everyone has a copy of this, everyone has a copy of, we had this value for the top of the blockchain, then we performed this transaction, this was the result. We performed this transaction, and this was the result. Everybody has a copy of the blockchain, so everyone can verify this. If somebody tries to say that instead of transaction 2 happened, transaction 2 prime happened. If somebody tries to say that, we can verify that very easily. We can say, okay, you said transaction 2 happened. Okay. So this was the last value. I apply transaction 2, and I get transaction 2 prime, and I get that. And this is the next value in the ledger. That's wrong. That's not actually what happened. That's what blockchain allows us to do. It allows us to make it so that there is a continuous chain of values at the top of the blockchain, the current value of the block, and a transaction. The current value of the block and a transaction. The current value of a transaction. The current value and a transaction. And another current value. if somebody tries to say, again, if somebody tries to say that transaction 4 didn't happen, it was actually transaction 4 prime, all we have to do is take this, apply transaction 4 to it. If we get something other than the next thing in the ledger, then if we get something other than the next thing in the ledger, we know that this is false, bad, no, wrong. That's what the process of verification is. So when somebody submits a transaction, everyone will perform a calculation on it, and everyone will say this is the next value in the calculation. If more than 50% of the verifiers agree, then that is the result, and that is reported as a valid transaction. There are actually bots out there that try to put in false results in here. They try to vote against the correct result, and actually they try to vote in their false result. So Bitcoin, the only thing it's susceptible to is it would be susceptible. Oh, that's fine. It would be susceptible to an attack if there were 50% plus one computers that were malicious computers in the Bitcoin chain. So if we had 49% of the computers doing the correct answer, and we had somebody trying to say transaction 4 prime is actually, if we had 49% doing this, and we had 51% doing this, we would actually be able to hack Bitcoin or any of the cryptocurrencies if we were to make this happen. It would be very, very difficult, but it is possible. And we're trying to guard against this, but this is the one biggest hole in the Bitcoin or the blockchain technology. If we have more than 50% of the computers who are malicious computers, yeah, sure, we're going to share the recording. If more than 50% of the computers are malicious computers, we can take over the blockchain. And we can start inserting bad transactions into it. Because if we submit this transaction to it, and we get this, and we expect to get this result, but we're getting this result instead, our transaction will either be deemed invalid or someone will have been able to insert the wrong transaction into the blockchain. Make sense? Does that not make sense to anybody? Very basic illustrative example of how blockchain works. We have a value at the top of the chain, then we apply this transaction to it, and we have a value we expect. We apply a next transaction, the value we expect. If at any time transaction and we get the wrong value, then we can say with a good degree of certainty that that is actually a bad transaction. We should not accept it. So the way we can verify that a particular Bitcoin transaction did take place is every Bitcoin transaction has a signature, which tells us which block it was applied to and what the transaction was. So all we need to do is look at the Bitcoin ledger. So let's say transaction 3 is pay you $250 from my account. So that this actually went through, we submit it to the verifiers. More than 50% of them come up with value. It's good. When we want to make sure that UC actually received this money, we go back to the transaction signature. We say, okay, it was applied to this particular value in the ledger. We apply the transaction to it. We make the calculation. We should get this. If we do get this, then we know that this transaction went through, and we know that University of the Cumberland's got $250 from my account. Are there any questions on how, at the very basic level, much more involved than this? Questions at the basic level, how blockchain works. All right. So now the answer is no. It will not help with plagiarism, and it cannot help with plagiarism. But what could it do? How could we use this technology? Any ideas how we could use this technology? So how about instead of so whoever's speaking, please mute yourself. Whoever doesn't have yourself and is not speaking, please mute yourself. So know this. We could potentially use this for student submissions and grades if we wanted to. So let's say this is the top part of the ledger. Let's say this transaction represents student A. Student A submits assignment 1, and we get this value at the top of the ledger. And then over here is Professor A, Professor David. Professor David grades assignment 1, and we get this value. This would, if we were to implement it, this would make sure that no one besides Professor David were able to edit that grade. So let's say, for example, someone tries to insert and it was a B minus. Let's say someone malicious tries to insert this. We will end up getting a different value for the resultant block than the true value. So if somebody says that this happened instead of this, all we have to do is take this level at the top of the block. We take the signature transaction that says it was applied to this particular point in the ledger. So for this transaction, we say it was applied to this particular point in the ledger. If we get anything other than this, let's say we get that. We know that this is a wrong transaction and we should reject it. It allows us to ensure that when we say that certain things happen, that those things actually did happen and they happened in the order that we say they happened. That's what blockchain ensures for us. Is this different from what you guys were getting from your reading? Or does this jive with what you guys were getting from your reading? Say yes or yeah? So how might this apply to our strategic plan? Maybe one of our goals or objectives is to decrease fraud in student grades and grade changes by 100% within the next year. And our strategy would be increasing security measures, and our tactic would be to use blockchain for submission and grading of student work. Does that make sense to everybody how we could use blockchain strategically to improve security measures? Yeah?
Yeah. Yeah.
The problem was possibly fraud with student grades. Sound good? All right. Now let's move on to virtualization. Some of you guys got virtualization a little bit wrong, so I'm going to demonstrate to you virtualization software right here. Where is it? I'm going to share my screen again. So this is Microsoft Azure. Microsoft Azure is a cloud-based service that allows me to spin up virtualized versions of pretty much any type of computing resource. Now, a lot of you seemed to think that virtual machine and remote desktop were the same. They're not. let's talk about how virtualization actually started. Oops. That's notes from another class. Notes from this class. Nope. It's notes from my optimization class. There we go. So virtualization started. We have server A and server B. Server A is a web server, and it takes 1,500 watts of power, and it has 5 gigabytes of memory, and it has a capacity of 1 terabyte. Server B is an email server. It also takes 1,500 watts of energy. It has 5 gigabytes, and it has 4 terabytes worth of storage. And these are what these things, the values that these actually take up. This 1 terabyte is actually the capacity. It's not how much is actually taken up. Let's say we are taking up 500 watts of power, but we're only using, let's say, 1 gigabyte. We never use more than 1 gigabyte in our very simple web server, and we're only using 256 of storage. So we are not using this thing to its fullest potential, even though we're still using 1,500 watts of power. I don't know if that's a lot or not. Even though we're still using 1,500 watts of power, we're only using 20% of our available memory and 25% of our available storage space. So we are wasting, essentially, 80% of our available memory and 75% of our available storage. Let's talk about our email server. We're still using 1,500 watts of power, but we're only using 2 gigabytes of memory, and let's say we're using 2 terabytes of storage. Again, we are not using everything to its fullest capacity. This is how we used to do things. We used to have physical boxes, we used to have a web server, we used to have an email server, and they were never used to their fullest capacity. So we were essentially wasting, so this is 1,500 watts. We're using 1,500 watts no matter what. But we're wasting, in this case, let's say 20%, let's just do an even 25%. We're wasting 1,125 watts. It's water that we still have to use to keep the server running, but we're just not using it. And over here, we're using only about 50% of the capacity, so we're wasting 750 watts of power. We're using power to keep these servers running when we're not actually using all of their computing resources. And that's when we realize we are wasting resources. So we decided, how can we make this better? Well, we can create server C, which is going to be our host, which is also going to use 1,500 watts of power, which is going to have 5 gigabytes of memory, and it's going to have 4 terabytes of storage. And inside of it, we're going to have a web server, which is going to use no power, but it's still going to use this 1 gigabyte and 1 terabyte. And we're also going to have an email server. Oops, sorry, 1 gigabyte and 256 terabytes, or 256 gigabytes. And we're also going to have our email server inside of this virtual host that's going to be using our email server inside. So we end up only wasting, let's see, 4 minus 2.25 is 1.75. Oops. we have space left over. We can put more resources in here. We're still using this 1500 watts, but we can put more stuff in here. What do we want to put in here? Let's put in another web server. And let's they say that one uses 1 gigabyte, and that one uses 256 gigabytes. Or we can even put in a third web server. Because of virtualization, all we need to do is run this one big computer, and we can run all these little tiny computers inside of it. And even, let's say, web server 3, it needs more resources. We can easily dynamically allocate new resources. And actually, no, we can't. We're out of resources. But let's say we want to allocate more storage. We can easily allocate more storage if we need it. Web server 3 might need more storage. That's what one of the powers of virtualization is. The ability to put different systems inside of our virtual host. This is just one piece of virtualization. This is called system virtualization, where we virtualize an entire system. It is possible, however, to virtualize anything. What are the different things you can have that are virtualized? One of the earliest examples is virtual memory. What is virtual memory and how is that significant? So virtual memory is hard drive space as if it were memory. What about a virtual device? What's a virtual device? Virtual device is software. What are the sorts of devices that you have seen virtualized before? I'll show you one. This is a virtual printer. You guys see this Adobe PDF thing here? There is no physical printer called Adobe PDF. There's also no physical printer called Microsoft Print PDF or Microsoft. All of these, none of these are actual physical printers. These are all virtual printers. These are all software programs that take the same inputs as a physical printer and do other stuff with them. So here's an example of a virtualized device. Does anyone understand that? What other things have you seen that have been virtualized? Other devices. We can virtualize a modem. We can virtualize a keyboard. We can virtualize a mouse. Any device we can virtualize as long as it's a piece of software. Oh, geez, this is freezing. You guys can still hear me, right?
Yes, we are hearing.
Okay, my computer's freezing. Sorry, give me a second. Let me stop sharing for a few seconds and see if it helps. Nope. Let me kill a couple programs to see if this helps. Come on. Sorry, my computer's freezing. Are you guys still there?
Yes, we are there.
Great. See the screen again?
Yes.
Okay, good. Yeah, I don't know why. It froze and it looked like my Windows Explorer, the desktop, just died and had to restart. I don't know why. So really anything we want, we can virtualize as a virtual device. We can have a virtual so a virtual service is a software used as if it were a service. So rather than mimicking the entire machine, we might mimic only a particular piece of software. And we abstract away the fact that the machine even exists, and we only interact with that piece of software. I'll show you an example. Here. This is called Microsoft Azure. This is what my company uses, my company called Array Analytics. This is what we use to host all of our applications. We have a number of virtual machines that we use. I can show you what they look like. This Geocodio Auto is a virtual machine that is it's a computer program that acts as if it were a full computer, and we use it to run our to run some long-running process called geocoding. Geocoding can take an address and turn it into a latitude and longitude. That's what we use. That's what we use this virtual machine for, because we don't want to run on any of our laptops, and we don't have any spare desktops running around, and we don't want lying around, and we don't want to allocate an entire computer just to use this. You'll notice it's stopped right now. We're not using this virtual machine right now, so all of these resources are freed up. All of the memory, all of the hard drives, all the stuff is freed up right now, so it can be used for other things. So virtualization allows us to only use the pieces of the big machine when we need to. Postgre Restore, this is a machine that we use when either backing up or restoring our database. And it's a very large process that we might need a lot of computing power for and a lot of hard drive space for, but we only spin it up when we need it. We must be doing something with it right now. But we spin this up, we run a big script on it. It takes several hours. But again, we don't want to run on any of our own computers. We don't want to have a desktop computer lying around that we only use for these sorts of long-running processes. But when we need it, we spin it up. We run the computer program on it, and then we spin it down. We also talked about service virtualization. These are all of our web services that we use. We have our demographics. We have our demographics service that serves data that's related to all of our populations, all of our patient populations. We have our facilities service that serves up data related to all of the healthcare facilities and healthcare providers all over the country. We have our geography service that serves up data related to all of the zip codes and all of the geographical information, et cetera, et cetera, et cetera. And by the way, these are all hosted on a virtual machine somewhere. However, we don't have to deal with that because all of the machine stuff has been abstracted away. And we are only dealing with the particular service that we're involved with. So this is a virtual service. Service is software used as if it were a service. And we don't have to worry about the machine. All we're worrying about is interacting with the particular software. We don't care what hardware it's running on. We don't care how much memory the thing has. All we care about is that this service is up and running and doing what it's supposed to. All right? And there are lots of other things that we can virtualize. We can virtualize a network. We can virtualize a database. And again, it's a layer of abstraction that allows us to only interact with the piece that we want rather than the entire system. It used to be, if we wanted to interact with all these things, we would have to install them all separately on the same computer. And we would have to go in and we'd have to log into that computer to deal with any of these things. If we're virtualizing them, we only have to deal with the particular one we're interested in. We don't have to deal with this big virtual host. We only deal with our web server. We only deal with our email server. We don't have to worry about how it's stored, how it's arranged, none of that. We only deal with the individual piece that we're working on. We can virtualize lots of things. We can virtualize services. We can virtualize devices. We can virtualize even streams of data. Let's say we want to load data, instead of from a file, we want to load data from a network location. That's okay. We can still access it exactly the way as if it were a file, but we'd simply virtualize it and access it via the same interface, but instead of coming from a file, it would be coming from a network location. So many of these things can be used for virtualization. We can do anything we want. It's not just a machine within a machine. It can be a service within a machine. It can be a device within a piece of software. It can be a machine within a machine, just like we talked about. Also, Java runs inside of a virtual machine. It's not a complete operating system. A lot of you thought virtual machine was synonymous with a complete operating system. It's not even that either. Java is not a complete operating system. All it does is run Java programs. It doesn't provide all of the services that an operating system would. All it does is provide services to run a particular computer program. So while a Windows virtual machine might virtualize an entire version of Windows, the Java virtual machine only virtualizes the application in which Java actually runs. Any questions on that? I felt it was necessary to explain because a lot of you are sort of getting misconceptions over what virtualization actually is. It's not just an operating system within an operating system. It can be many things. It can be a device within a piece of software. It can be a hard drive within a device, within a piece of software. There are lots of things that can be virtualized. Any questions? So my final question of the night related to this is, how can potentially University of the Cumberlands use virtualization strategically? This is pretty easy. I'll answer that for you. To use virtualization strategically, the University of the Cumberlands can, instead of buying its own email server, web server, etc., University of the Cumberlands can host these things inside of the cloud and only virtualize an email server. Maybe we only want email services. We don't want to deal with maintaining the updates to the email server, making sure all the operating system is up to date. Maybe we could only rent a virtual email service. So this is what would be a virtual service, or a software as a service. There's software as a service. Let me just write these down. There's software as a service, and that would be if we're going to rent an email service. There's platform as a service, and that's an application running environment as a service. There is what is it? Infrastructure as a service. There's network as a service. All of these things are nowadays usually based on some kinds of virtualization. And if we're using network as a service, we are only dealing with the network. We don't get access to any of the other things it's running on. It might be running on a virtual machine, might not be. It might be running on a physical machine. There may be a physical network behind it. There may not be a physical network behind it. It may be running totally inside of a piece of software. We don't know, and we don't care. That is a level of abstraction or a level of virtualization that is taken away from us that we don't have to deal with. So virtualization makes management very, very, very easy. We only deal with the piece of the system that we are concerned with. Everything else is abstracted or virtualized away from us. That's one thing we could use it for. We could also use virtualization, in a way, software as a service, Blackboard. When you log into Blackboard, you're not actually logging into the University of the Cumberland's site. You're logging into Blackboard's site. And Blackboard is providing that as a service to us. It is probably virtualized in some way. But the virtualization that we are concerned with are the fact that all of the memory management, all of the updates to the operating system, all of the security pieces, those things are all abstracted away. And all that Cumberland's has to deal with is the actual application and configuring of the application. Does that make sense to everybody? Are there any questions on virtualization or infrastructure as a service? Yes. Are there any other questions on Bitcoins, cryptocurrency, blockchain, and virtualization? We took about an hour and a half for today, so we're supposed to have 45 minutes. So it took up 2 weeks of your time to make up for what we didn't have. Any questions? I went through the first 3 weeks pretty quickly. Because remember, I sent you guys over the first week because you weren't prepared. Everybody's good? Again, now that my life has settled down, by the way, would you please pray for my friend who recently died? They were very close to me. One of them lived here in DC. I saw him all the time. He was a young entrepreneur. He had a business that he was very successful with after only. And his death was felt throughout the community here. We were very saddened about him. Another one was from the area, but I saw him all the time when I traveled. Who is talking and not muting yourself? If you're not speaking, please mute yourself.
Turn left south. Head west on West Court Place toward North Upper Western Drive. Then turn right onto make a U-turn at West Randolph Street.
There we go. All right. So I say again, my friends who recently died, one of them was a young entrepreneur. He was only, I think, 29 years old. Actually, he died a couple days short of his 29th birthday. We're having a memorial service and fundraiser for a scholarship set up in his honor. For he was a Korean immigrant. We're setting up a scholarship fund in his honor to help Asian immigrants who want to start businesses and who want to learn. We're having a big fundraiser for him this weekend. And the other one was from San Diego and from California. I don't know the details on whether there's going to be a memorial for him or not. But I'll probably be traveling out to San Diego or San Francisco where he lived for that pretty soon. Please keep these. If you believe in a higher power, please keep these people in your prayers. Doesn't matter which higher power you believe in. If you don't at all, just please think of my friends who recently died. They were very special to me, and they will be very, very, very sorely missed. Yeah. Anyway, anything I can help with you guys all? Yeah, is everybody good?
Yes, Professor, we are good. And I'm sorry to hear that. And may his soul rest in peace.
Thank you. They were very nice. I was completely shocked to hear about both of them. And they were both just they were both tragic accidents that happened very quickly, very close to each other, and many of the people who knew them knew both of them because they were part of the same community, and we were just shocked to hear about it. Anyway, all right. So I will see you guys next week. We'll talk about the topics for next week as well as the assignment and lots of things. Also, some of you, I sent your assignments back to you. Thank you for getting them back so quickly. Yeah, so by the way, one of the things that I'm doing, I usually do it every term, is if your assignment is just really, really, really bad, I'll assign a placeholder grade of 0. It's not a 0, but I have to assign a grade to be able to give you feedback. So it's just a placeholder. Once you actually resubmit it, and I know some of you have already done that, which is wonderful. I love it. then I will review it and assign a real grade. So just don't get upset if you see the 0. You should only actually get a 0 on any of the assignments in this course if you don't turn something in, or if you turn something that's really, really bad and don't fix it. All right? So please don't get upset if you see the 0. Just say roger that. Just read my feedback, say roger that, and make the necessary corrections. Thank you. All right. I'll see you guys all next week. I'll make an announcement on when we're going to have next week's meeting. And thank you all for coming tonight. Good night.
Thank you, Professor.
Bye.
Bye.